Hello, Mobile Optimized. I hope you are safe and healthy at home, and thank you for tuning in. I'm excited to be here talking to you about a topic that's fascinating me over the years, which is state management. But before I start, I just want to give a quick thank you to the Mobile Optimized team for all of their hard work in putting on this amazing conference in what has been an interesting and unexpected year, and hope to come visit Belarus in person once travel is back to normal sometime in the future. Speaking of this past year, I have been lucky enough to have spent significant time back with my family. I am the oldest of five, you can see them here on this slide, and it has been great reconnecting. However, this means that I've been working hours in the same vicinity with my younger sister, who just happens to be starting medical school, with the first semester being taught online. With everything I've overheard this past few months, I too feel like I have started medical school. But I did notice while writing this talk that there were actually a lot of parallels between medicine and software engineering. So I'll try to explain state and state management from my dual perspective of a pretend medical student and software engineer. So why states and states management? I've always been fascinated by this topic because it permeates every software domain, from cloud infrastructure to back-end development and to mobile applications. But I began to notice the meanings change depending on the domain, the developer, and the use case. I was interested if there was one unifying meaning that ties all the different use cases and terminologies together. Just in my experience alone, I realized my understanding of state has evolved dramatically. It started out while working in cloud infrastructure, where I thought of state as a simple FSM, or finite state machine, which meant that state is a concrete value limited to one of a few options. This I understood. However, I next encountered state while working at a startup building real-time collaborative tooling, which you can think of as Google Docs, which allows users to simultaneously work. Here we thought of a state as the latest and most recent data and spent a lot of time syncing states trying to figure out what the latest actually was. As you can see, this differs from the simple concrete model I started from, as the state was continuously evolving and progressing. Finally, when moving to mobile, I again noticed these terms being used, but with completely different meanings and uses. I decided to dig deeper into the topic to understand what people are really trying to convey when they use these terms, and I hope to share my learnings with you today, with the goal of giving you a better understanding of what state and state management means, why so many frameworks and libraries exist, and how to best apply them for different use cases. I will start things off by sharing what I discovered from my research into state and state management, and how I came to a clear understanding by drawing parallels to the human body and its health. I will then go into a quick overview of some of the more popular state management frameworks and libraries, and how these can be thought of as medical treatments. Next, I will explore how to properly understand your application's requirements and why this is as important as properly diagnosing a patient's symptoms. And finally, I'll go through two working examples illustrating the steps to build a better state management solution and how a well-built solution is akin to a healthy patient. While narrowing down on my own definition of state, I came across many differing and incomplete definitions. For example, from Wikipedia, they define a stateful system as a system designed to remember preceding events or user interactions, and the remembered information is called the state. Technopedia describes state as the last current values or contents, and PCMag describes state as simply the current or last known status or condition of a process, transaction, or setting. The main similarities I found in these definitions are the facts that they all incorporate some sort of temporal aspect, that is, state is always changing over time, and the other is that state includes values or information. Now, switching to my alternate medical persona, I initially thought of a state as the body, but this was too simple. Like state, the body is always changing, as anyone who has seen themselves on Zoom calls these past few months can relate to. And the body changes depending on the activity or the goal. For example, training for a marathon will have different impacts than binging Netflix. Therefore, I like to think of state as how the body is performing and what it is currently trying to do at a given moment of time. And translated to engineering results in state being defined as the information and behaviors of the app at a given moment of time. Using these definitions from both the medical and engineering fields helps us understand the different uses of state I encountered in the mobile context. For example, state objects store information needed for the rest of the application, just as the brain stores information needed for the rest of the body to function. State classes can be thought of as the body's muscles, which uses information from the brain to enable the body to reach the desired goal. For example, to reach the goal of running a marathon, the brain will send information to the muscles, telling them to move, while they also incorporate new information from the environment, such as how tired and full of lactic acid they become. Similarly, state classes use information from the state objects to enable behaviors in the app, and can also process new information generated from user interactions. Finally, the activity the body performs is the visible outcome of the brain and muscles, just as the stateful widget is the visual outcome of the state object and state classes. Things get murkier and more complicated when we start talking about state management. It has become a catch-all term and can be seen used in a variety of areas with completely different meanings. Just as health can be used in a variety of contexts, such as healthy food to having a healthy appearance, state management can be used in context from anything describing data persistence to UI templating. However, I believe if we use our earlier definition of state, we can come to a more concrete definition of state management. And the reason why state management is so hard to define in the first place is the fact that it is really not just one thing. It is not a framework or library. It is not a data store or database. If we think of state as the information and behavior of the app at a given moment in time, then state management can be thought of as a solution to control this flow of information and interact with its behavior. Similarly, if we think of state in the medical world as how the body is performing and what it is currently trying to do, then state management can be thought of as the plan to keep the body healthy. Both of these definitions are intentionally vague, since in every case, whether an application or patient, a unique solution or plan is required and can vary immensely depending on the problems faced. However, this does not mean that patients or applications are never facing similar problems, and in fact the opposite is true, which is why we have many standard medical treatments as well as state management frameworks and libraries. Now that we have defined state management as a plan to keep the body healthy, the question becomes how to develop and execute this plan. This is where different treatments come into play. For example, for a minor scrape, you may simply need a Band-Aid, whereas more advanced cases that include headaches or other pains require medications. Each of these treatments have different purposes and side effects, and even if one treatment may solve the problem, it does not mean it is the best solution. For example, you can choose to go to the hospital for a minor scrape, but they ultimately just give you the same Band-Aid you could have simply gotten at the store. Similarly, state management frameworks and libraries can be thought of as treatments. They too differ in their purposes and side effects, and just as you would first research different treatments and medications, you should understand the different frameworks, how they work, and what problems they are best suited to solve. I will dive briefly into a few of the more popular frameworks, and then we'll get to some of the examples later on. The first framework I'd like to go over is MVC, which is well known for its three-layer architecture and divides applications into three components. The first is the model, which maintains the data or information of an application. Then there's the view, which displays the model in the UI to the user, and the controller, which serves as an interface between the view and model components. So whenever the controller receives a request from the user, it modifies the model and then tells the view to re-render the model. The view then displays the updated model to the user. MVC is actually one of the oldest frameworks out there and came out from the early development of graphical user interfaces. MVC became one of the first approaches to describe and implement software constructs in terms of their responsibilities, so essentially splitting out the different responsibilities between these ones. It started to become formalized in Xerox in the late 1970s and has spawned many iterations, including the MVVP and other frameworks. Next is the Redux architecture, which is an especially popular framework in web development, and has started seeing some traction in mobile as well. Redux is broken down into reducers, which contain logic that decides how the data is updated. A centralized store, which holds a state object or the information that denotes the entire state of the application. And actions, which signify events that modify the application state. So the way it works is that an action is triggered from the view or external source and is dispatched to the reducer. The reducer then updates the centralized store with new data based on the action it received, and the store creates a new state and sends it to the view to be re-rendered for the user. Redux was created by Dan Abramoff and Andrew Clark in 2015 and was started as a proof of concept working on a way to time travel or move between different states both forwards and backwards. Here we have the MVVM architecture, which stands for Model, View, and View Model. As you can see, it is similar to the MVC framework discussed earlier, but with slight changes. Here, the user interacts with the view and sends a request to the view model. In the previous MVC framework, this was the controller. The view model, which also, you can think of as the controller, similarly modifies the underlying model. However, the difference is the view now renders the view model directly instead of the model itself being rendered. This serves to isolate the model from the view. Finally, we have the block library, which in Flutter is one of the more popular libraries and is a version of the MVVM, but without the model. Instead, the view model contains all the state and state transitions and provides the view directly the information it needs via streams. So the view model takes an input of event streams, updates its internal model, and outputs a stream to the view to be rendered. Typically, with this architecture, each view model will correspond to a single underlying model or object. So instead of having one large model or controller or store, there'll be many smaller view models. Block actually stands for Business Logic Components, and was first used by the AdWords team at Google, who want to use Flutter for their mobile apps, but also wanted to share business logic with their Angular Dart web apps. It was introduced at Google I/O in 2018 to simply show a way for how developers might choose to integrate business rules with Flutter widgets. As you have learned, none of these frameworks are the result of numerous performance tests or research, but more as a result of trying to solve for a specific problem and then generalizing it in a way to potentially help in similar problems. The key is then to understand your problem, which can help narrow down what tools might work best. And here I have noted a few high-level features to help highlight some of the differences between the frameworks to help us compare. This is certainly not comprehensive, and more of just an illustration to help us get started thinking about the different frameworks. First, we have the data direction flow. As you saw in the previous diagrams, Redux is unidirectional flow when compared to the bidirectional flow of Block and MVC. This can help with debugging and understanding transitions, as everything is sequential and is easy to step through. Next, while all three can split up into their components and modularly tested, Redux is nice since it contains a single store and can run middleware to help make testing and debugging quite easy and painless. However, one of the downsides of Redux is that it works best in synchronous solutions and requires extra work for it to work correctly in an asynchronous mode, whereas MVC and Block are much better suited for asynchronous work. Redux can also run into problems when the store becomes too large, causing significant performance implications. As I mentioned earlier, before you jump into selecting a treatment, you should properly diagnose the issue. To do that, you must ask the right questions. One way to frame the question to determine your requirements and needs is to ask your question without the words of state and state management. That forces you to think clearly and directly at the problem you are trying to solve, and consequently use the correct tooling and architecture to solve that specific problem, and not the general problem of state management. For example, the wrong way to go about it can be seen in the Stack Overflow question and answer. The question of how to manage state can be rephrased to how to trigger animations on a user interaction. The solution is not to simply use a state management library like this answer suggests, but instead learn more about what are the different user interactions. Is it just one or could it be multiple? What types of animations are there? Do they depend on multiple things, or is it just a one-to-one mapping? Only after answering these questions can you start building out your solution. Just as a doctor will go through a series of steps to create a plan of care, so too must you go through a series of steps to create your state management solution. The doctor will begin by asking a series of questions regarding the patient. Where does it hurt? How long has it been hurting? What are you trying to accomplish? Next, they will determine the symptoms. There is pain in these specific muscles and only seems to occur on long runs. They will then begin to create a plan of care. Maybe have the patient take time off of running, or maybe they require running additional tests to get more detailed information, such as ordering an MRI. Only once they have a complete picture will they execute their plan and prescribe a treatment. Similarly, the developer should begin by understanding the application. What are the key components? Why is the application being built? What information will be used? Next, the developer should determine the behaviors of the application. What is happening with the information? How should it be displayed? After these questions are sufficiently answered, can the architecture be created? If possible, core components should be performance tested to further understand how the solution will work. Once these steps have been completed, then it is time to build the state management solution. For the first example, as illustrated here, we will be building a real-time data dashboard with 6 panels. Each panel is displaying data that receives from a random data generator that produces data every second. The first step in designing our state management solution is to understand the application by asking questions such as what the application is and what information is being used. In this example, our application consists of a series of panels that are all independent. They each take in an array of values to create a graph, and it is important for users to see the data as quickly as possible. Next, we want to determine the behaviors. In this example, data will be generated every second. Users will be able to toggle each panel on and off, and the data is never saved. Now that we have a better understanding of the application behaviors, we can begin designing our architecture. One possibility would be to use Redux. In this case, the data generators would produce data events that would be dispatched to the reducer. The reducer would update the store and re-render the view. One problem with this architecture is that the view is re-rendered any time the store changes, and because there is one store, each panel will cause the store to change, causing many extraneous re-renders. Another possibility would be to use the MVC framework. In this case, the data events would be sent to the controller, which would then update the model, and then notify the view to re-render the model. This architecture also has the potential to cause extra renders and kind of performance limitations depending on how the MVC is implemented. For example, the controller can tell the view to re-render on every change to the model, or try to group model changes together to limit the number of renders. This illustrates that even if you choose a framework, there are still many design choices to make. Just as when you take medication, you must decide the dosages and how often to take it. Finally, there's the block architecture. In this case, the data event is sent to the model view, which updates its model and triggers a re-render of the view. The nice thing about this architecture is that each panel can be separated out and rendered independently. So there would be 6 model views or blocks instead of having one singular controller or Redux store. This ensures that each separate model view will only re-render its corresponding panel and would not affect the rest of the dashboard. While we have a good idea of how these different architectures would perform, it's still good practice to run performance tests, especially if this feature will become the core component of a much larger app. And I did run some basic performance tests with the results displayed here. For the test, I used the timeline feature, which is available in Flutter DevTools. This records the frame render time for the UI and the frame time to actually draw the raster elements. Here, we want to look at the light blue bars, which depicts how much time it takes to calculate and render each new frame. In this test, I toggled all 6 of the panels to be on and plotting data and record the performance over 5 seconds. I will provide the GitHub link to the code at the end of the presentation for any of you interested in looking at it and running your own tests. Looking over the results now, as predicted, we can see that Redux performed much worse than the other two, with Block having the best performance. As mentioned earlier, the reason why Redux performed so poorly is that with one central store, every new piece of data for any of the panels creates an updated copy of the store and triggers a re-render of the full view. MVC is able to perform better since the controller can update each panel slice of the model directly as new data comes in and trigger a re-render just for that panel. But there are still performance limits, as a single controller requires time to continuously look up and process each panel. Block performs the best, as each panel is completely independent by having its own view model or controller. This independence allows each panel to immediately render itself as soon as new data is available without sharing any resources or rendering calls with each other. And while we could make some changes to Redux to increase performance, such as creating multiple stores or batching the data events together, this is still trying to use the wrong medication to solve the problem. Just like trying to take pain medication to reduce the pain without trying to fix the actual issue causing the pain. It may work in the short term, but in the long term, it will cause more problems and may even leave lasting damage. Just like a bad architecture may work in the short term, but will leave enormous amounts of tech debt behind. Now that we have a good idea on what framework and architecture to use, we can begin to implement our state management solution. And just like in medicine, where it's good to have follow-up visits to make sure the treatment is working, it is good to periodically test and ensure the state management solution is in fact working. Now, I'd like to go through another example that is much simpler to show that the steps mentioned earlier can still apply, while also showing the importance of thinking not just on the application you tested to build, or your task to build, but what else may be implemented in the future. This example is a store catalog that contains a large list of products, which each contains various reviews. As we did before, the first step in designing our state management solution is to understand the application. In this example, our application consists of products, reviews, and a shopping cart that contains products that a user has selected. The behaviors of this app include displaying the catalog of products, retrieving and displaying reviews based on the selected product, and keeping track of products that the user selects in a shopping cart. Now, designing the architecture, we will again compare the different frameworks we did in the previous example. In the Redux framework, a user will interact with the view by clicking on a product to either list the reviews or to add to the cart. This action is sent to the reducer, which updates the store and renders the updated information. In the MVC model, the user again interacts with the products, and the corresponding action is sent to the controller. The controller updates the model and then tells the view to re-render. Finally, the block framework can be implemented by creating separate blocks for the cart and the catalog. Clicking on a product to review or to retrieve reviews will trigger the catalog block to retrieve the reviews and render them in the view, while adding a product to the cart will trigger the cart block to add the product and re-render the cart. While you can see all these frameworks handle this simple example very well, with minor differences on where the information is stored and how the view is rendered. Running performance tests on this example yields no surprises, with the performances being essentially the same. And for the tests here, I simulated clicking a product, retrieving the reviews, and then going to the cart and listing everything in the cart. So you can see here in the diagram, the large red, kind of in the middle of the graph, is when we're toggling to the cart, which triggers a re-render of all the products in the cart. And you may conclude that this proves that any framework will work, since both of these graphs are essentially the same, and to simply choose the one that requires the least amount of boilerplate code, or use a framework that you're most comfortable with. And while these can be factors in making your decision, I think the fact that these performances are so similar show that you may not have the complete understanding of your application, and I challenge you to learn more before moving on to the next step and building out your state management solution. For example, a doctor may have many patients with the same injury, but looking into what the patient is planning on doing in the future may impact what type of treatment should be prescribed. For instance, a professional athlete needing to perform at the highest level may require different treatment than someone who can maybe deal with a little inconvenience. Similarly, in this example, if you expect more data sources to be incorporated in the future, such as customer ratings or related products, and maybe you want to track the user journey through your app, Redux may be the right solution, as it maintains a store of all the relevant data that is pretty static and can track user actions and behaviors in middleware. However, if you envision constant streams of updated prices and maybe bidding type actions, then Block may be better suited for that use case. The point I want to make is that many of these tools and libraries will work for whatever application you need, but how easy they are to implement, how well they perform, and how simple they are to debug will vary, and it's up to you to decide based on your specific use case. Now, I wish my talk ended with the one catch-all solution that you can use in every situation that was simple, performant, and required only a few lines of code, but unfortunately, that is not the case. Instead, we came up with a definition of state as the information behavior of the app at a given moment in time. Using that, we define state management as a solution to control the flow of information and interact with its behaviors. We then went over a few of the frameworks in some detail, but I encourage you to explore more, as I just touched the tip of the iceberg on what's out there. And finally, we went over the steps to understand, evaluate, and build the correct state management solution for your particular application. Overall, just like a doctor should understand their patient and their symptoms before selecting the right treatment, so too must you, as the engineer, understand your application and its behaviors before creating the right state management solution. With that, I'd like to thank you for listening and open it up to questions and comments. I can also leave my email address if you'd like to connect offline, and we'll post the code for the examples on my GitHub as well. These are all posted here. So thank you again, and I would like to open it up now.